The purpose of this course is to provide basic information about Wireline, how it works, and its purpose. Gyrodata uses Wireline with many tools and services. It's proven technology for which the company has earned a reputation for reliability. It would be impossible for this course to teach you all the details of doing a job. Instead, let's look at how to prepare for one, what equipment to pack before leaving the shop, and which tools to put in the toolkit to handle any problems that could arise. And finally, we'll walk you through, step by step, how to rehead a teardrop. This is one of the most common and most important field jobs. Without a teardrop, Wireline won't work. Let's start by looking at the purpose of Wireline and the principles behind it. Wireline actually does three things. First, it lowers the tool into the ground. Hanging on the end of the wire, a tool descends as it is spooled from the truck. It also raises the tool when its work is done. Second, it provides power. Unless it runs on battery, a tool requires electrical current from a power source, like a truck or an electrical generator. Wireline delivers the power. Think of it as a long extension cord that runs into the ground. Finally, Wireline sends data back to the surface. The tool, like a gyro for example, takes measurements and converts the data into electrical form. The wire returns the data to the truck where it can be analyzed, almost in real time. Most Wireline trucks have a socket or plug that can power the tool, but sometimes operators may also bring a generator. The generator may serve as a backup if something goes wrong with the truck, or as the primary power supply if the downhole tools have power requirements the truck can't meet. The picture on the left shows the truck hookup, and the one on the right, a generator. When a tool takes measurements, it converts them first into digital and then electrical form that can be sent back to the surface, not unlike a network connection on a common computer. On a survey, it's the Wireline that delivers the data. It travels up the wire where it's eventually fed into a computer. Sometimes a tool may be lowered thousands of feet into the ground, and with few exceptions, it just can't be dropped. It wouldn't withstand the impact at the bottom. So the tool is suspended on the end of the Wireline. A spool on the back of the truck gradually unrolls, releasing the wire at a controlled speed. Not only does this control the descent, it allows the operator to know precisely how far down the tool has gone. A measuring head calculates the amount of wire the truck has unrolled. Along with the wire, several other components play a part. First, there's the truck. It carries the spool with hundreds of feet of wire, and inside the truck, there's all the computer and electronics gear required to analyze the data sent by the tool. Next, there's the cable head. It physically connects the Wireline to the tool. We've already mentioned the measuring head. It records and monitors how much Wireline has been unspooled from the truck. Finally, there are the sheaves. Sheaves are large pulleys about 3 feet in diameter that help control the wire's tension and direction as it comes off the truck. While it's true trucks carry and release Wireline, they also do much more. Inside, there's a control center from which the job is controlled and coordinated. Computers analyze the tool measurements. Switches or levers control the speed the wire is released and regulate important variables like hydraulic pressure. The cable head connects the wire to the tool. It actually consists of a number of parts, including a teardrop and knockdown. But it's more than just a simple connector. It's also the way power is transferred from the truck to the tool. The measuring head does exactly what its name implies. It measures how much wire line is spooled out from the truck. Some older models are mechanical, while more recent ones, like the one in the picture, display data using a digital readout. With the measuring head, it's possible to know how far down the tool has traveled. The sheaves are large pulleys that help uncoil and direct the wire line once it comes off the truck. Every job uses two, one on the rig floor and one on the derrick. The first sheave positions the wire correctly on its way up. It also helps control wire line tension. For example, if you want the tool to drop faster, the sheave can allow more slack. The opposite is also true. The sheave can tighten the wire to slow it down. Before leaving the shop, always make sure to have at least 3 sheaves along, with stands to set them on. Now let's look at how to prepare for a job. There's a lot to bring. Before leaving the shop, consult your supervisor and the list with all the supplies you'll need. Reheading tools are especially important. Some things to remember include the rehead toolbox, at least 3 teardrops, and 3 sheaves with stands to put them on. The following slides provide a more comprehensive list of what you'll need. The teardrop is essential because it transfers current from either the truck or power supply to the downhole tool. Without it, it's impossible to do the job. The rehead toolbox should contain everything you need to rehead a teardrop, should it fail on a job. The sling secures the upper sheave to the derrick. Later in the course, you'll see that during a wireline job, that sheave may move up and down, sometimes a number of feet. The sling makes sure it stays securely in place. The chain makes sure the lower sheave is securely fastened to the rig floor. Overshots are a type of fishing tool. That means if a tool gets lost downhole, then an overshot can be used to retrieve it. On a wireline job, an example might be if the line breaks, but sometimes companies call gyro data to retrieve tools lost on an MWD job as well. The collector ring is basically a swivel. It moves with the wireline drum and allows the wireline to feed out without getting tangled or broken. The connector ring cable is used to hook up or connect the connector ring with the wireline power supply. Sheaves are large pulleys about 3 feet in diameter that help direct unreeling the wire. There's usually 2, one on the rig floor feeding wireline up to the derrick, and a second on the derrick that helps direct the wire in the right direction as the tool goes downhole. They also play a part in controlling wireline tension. Sheave stands are the mounts used to hold the sheaves in place. Simpson meters measure electrical current flow. They detect short circuits or can confirm that current is flowing properly through the wire line itself. Line cutters are large wire cutters used to cut through the wire line itself. Wireline cable is thick by most standards, 5/16 of an inch. The weight bar is most often used with the overshot, helping it to get it downhole to retrieve a tool, but it can also be used on the wireline itself to help force it down the hole either further or faster. Line wipers are used to clean dirt and debris from the wireline as it comes out of the hole. And finally, tire chocks are used for safety. They are placed behind the wheels of the truck to keep it from rolling while parked. Teardrops are part of the cable head. They transfer power from the truck or generator to the wire line and onto the tool. Without one, the job can't be done. Another name for installing a teardrop is called reheading. The next few slides will look at the parts you need to do that. Reheading the teardrop requires a lot of tools. It's important to make sure you have them all before leaving the shop. You can only use one teardrop at a time, but because they're so essential, you have to make sure to bring at least 3 on a job. The more the better. Scotch 33 tape serves 2 purposes. First, it works as a connector, making sure the wire stays secure. But it's also important because it helps insulate the teardrop from both moisture and heat, both of which may be intense when the tool gets below ground. Rubber tape is also used and serves much the same purpose as Scotch 33. It provides added security and an added layer of protection. At one point during the installation, you'll have to remove a plastic sheath from the wire to thread it onto the actual teardrop. That's what the wire strippers are for. Wireline is a thick cable, 5/16 of an inch thick. It requires stronger wire cutters able to get through it. Wireline pliers have a notch carved into them that holds the wire firmly in place while it's being worked on. For example, at one point during a teardrop installation, small individual strands of wire must be peeled back. The pliers hold the main wire tight so this can be done. Dikes are similar to standard wire cutters you might find at a hardware store, but on a wireline job they are used to pull back the smaller wires that surround the main core during the installation process. Later in the course, we'll walk you through that process. A large metal hammer is used to secure the knockdown, a part used to hold the wire in place to keep it pulling free from the teardrop. The 211 O-rings are used to protect the teardrop from both dirt and moisture. Be sure to have a good supply on hand. A box knife is also used to strip the wire. It's used to cut the plastic sheath surrounding the teardrop's main wire. Along with the hammer, the knockdown tool is used to hammer the knockdown into place. Feed the teardrop's wire through the slot shown in the picture and then hammer the tool on top of the knockdown to secure it firmly in place. The knockdown remover does the exact opposite of the knockdown tool. It's used to remove the knockdown when taking the system apart. Anti-seize is used near the end of the assembly process. It's used to lubricate the threads when it's time to screw everything together on the rope socket assembly. Set screws are also used near the end of the assembly process. They are used to secure the rope socket assembly to the knockdown inside. The two parts are aligned and then the screws firmly placed to hold it all together. Use an Allen wrench set to tighten the set screws. Use O-lube to moisten and lubricate the O-rings used to keep dirt out of the teardrop. The rope socket is a metal piece that covers the teardrop and knockdown. It's the part that holds everything firmly together and that actually connects to the wireline. The pipe wrench is used to assemble and disassemble the tool. The following slides will show you how to properly rehead a teardrop, step by step. Carefully align the end of the wire with the threads on the teardrop. Mark the correct point with the dikes or wire strippers so that you know at what point to start stripping the wire. This will ensure the wire is long enough to connect properly to the teardrop once the sheath is cut in the following step. Secure the knockdown in a vise and then carefully cut through the sheath of the protruding wire. Use a set of dikes to pull off the sheath. Feed the bare wire through the small hole at the end of the teardrop. Wrap any excess around the insulation at the end. Carefully wrap the wire with insulating tape. Use both rubber and Scotch 33. Different operators have different ways of doing this, so talk to your supervisor for advice on the best approach. But be sure to be thorough. The tape not only secures the wires, it protects them from dirt and heat. Slide the rope socket you assembled at the beginning of this process over the teardrop and knockdown. Then secure the assembly in a vise. Lubricate the threads by liberally applying some anti-seize. Another name for this is copper coat. When the threads are lubricated, screw the two parts together. Align the hole on the knockdown with the one on the rope socket assembly. When you turn the knockdown, you'll be able to see when the two line up. Then apply more copper coat, this time to the set screw. When you're done, use an Allen key to screw it into place. That's it, you're done. We've covered the introductory material intended for this course, but you might be interested in seeing how it all comes together in the field to work. The next few slides will show Wireline in action on a real job in South Texas. Watch the video as the operator in the Wireline truck runs the controls. There's a lever that lifts or lowers the tool in or out of the ground, buttons to control hydraulic pressure, computer displays and readouts. If you watch closely, you can see the large wire spool on the truck letting out wire when the operator moves the controls. This video shows the other side of the operation. Watch as the Wireline spools off the truck, travels through the measuring head, and then up to the rig. Notice as it passes through the sheave, moving up and down as the tool is lowered into the ground. There's a person on the rig watching the whole process, and by using hand signals, he or she can send instructions back to the person in the truck. Wireline jobs truly are a team effort. Now it's time for the final test. Read each question carefully and provide the best answer. Good luck.